are going to be talking mostly about style guides in Python, how to respect those guidelines proposed by Python developers so that other developers could easily read and understand our code. We will be talking about useful tools called linters and formatters in order to basically stylize the code for us. And we will also talk a little bit about Python scripts, the .py files that I showed you in the first lecture. And also we'll be also talking about how to use modules and libraries and packages that other people have developed, a couple of comments about that. And finally, I will again go over in more detail on the behavior of Python that we have seen in the previous lectures related to copying variables to other variables, and sometimes that it doesn't get copied, and sometimes the values and the data gets copied. So I'm going to be going deeper into that topic, and that will be our lecture. If we have more time, maybe I'll probably jam in one other topic into this lecture, but if not, then that'll be it for this lecture. Okay, let's get started. So, I'll start this lecture by saying that the code that we write has two users. It's not that you just write some code and then if it runs fine on your computer or on another computer, then that's it, because usually the code is read by the computer and it is also read by other humans during the lifetime of the code. So it's very, very important for us to be able to write code that is stylistically correct as well as syntactically correct. So each language has their own set of style and formatting rules, and Python is no exception in this regard. So there is this design document providing information about Python, which is called PEP, and that's short for Python Enhancement Proposal. And I'm going to paste that here just so that we have that over here. Okay, PEP, Python Enhancement Proposal. And then, for example, one particular page of this proposal talks about writing docstrings. For example, what is the standard for writing docstrings? That's PEP number 257. Or we have another PEP document which is called PEP 8, and that's the one that is the style guide for writing Python code. Okay? And what we will be discussing in the next few minutes will be based on this style guide for Python code. You can look it up, you can go through that, and it basically just outlines what are the things that we have to do when we write code in Python in terms of style, and the things that we should avoid basically doing. So up to this point, naturally I have seen you writing code not in the most Pythonic way, so to speak, but from this from the next lab onwards, we will also be looking for these formatting conventions, whether you respect those, whether you abide by those or not, and that will be part of your grade. Okay. So if we do this, Python has a nice set of guidelines, like the philosophy of writing code in Python, and these are the set of basically the basic rules that we have in Python. If you say import this, it will show you the Zen of Python. For example, beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And there are explanations and examples for each of these statements that you can find online. But it's basically, when you get used to it, you'll understand quickly what is meant by each one of these statements. So for example, here it mentions that, let's suppose that you can do some code on just one line, okay? But it makes the code look very complex. It makes it less understandable. And Python tells us, the guideline tells us that, for example, explicit is better than implicit. So instead of putting everything in one line so that to show others how elegant of a programmer you are in Python, you can probably break that up in a few lines and clearly show what your logic for writing that piece of code was. This is just an example of what, and this also could overlap with readability counts over here. So you can take a look at this Zen of Python here and draw some inspirations from that. But here I'm going to go over the highlights of PEP 8, the document that gives us the guidelines for styling our code, and I'll give you a summary of what's contained in that. Okay. So we'll start from naming conventions, and here we are. So for variables, functions, modules, and packages, we use lowercase words separated by underlines. So my underscore var x, or divided underscore by underscore 3, and names like that. So we have to avoid having capital letters in those names for variables, functions, modules, and packages. However, you have seen in the previous lecture that we have, for classes, we use what's called camel case, meaning that we capitalize the first letters of the words without including any underscores. So that's the convention for naming classes. Okay? And note that we don't use any underscores. And the thing is, if you do use underscores, nothing happens syntactically. There's no error, but stylistically, it will be incorrect. Okay, sometimes you have code that is too long for one line, so you might want to break it up into several lines. In Python, there's two ways to do this. So let me first show this line over here. Okay, so we are limited to 79 characters per line. However, you can break these lines apart by using in two ways. One is by using backslash actually, and that's something that's not recommended. Okay, but the recommended way is to use open and close parentheses wherever possible, or whenever you have other types of brackets, then that would also work. Okay, let me show you an example here. For example, you're defining this function, and you have a long list of arguments. Because this list of arguments is already supplied inside of open-close parentheses, you can hit enter wherever you like, and then break that line down into several lines. Okay? So even if you're outside of a function or anywhere in Python, whenever you need to break down your code into several lines, you can wrap everything around an open and close parentheses, and then hit enter as many times as you like. Okay? All right, let me give you another example. So whenever you have operators, then in that case, it's better to style your code like this. Okay, so here we have the open and close parentheses, and then the operators appear on the next line. Okay? Potential plus kinetic plus inertial, internal minus friction. Okay. And sometimes when you write code, you might have already seen it in VS Code, because it automatically, when you hit enter, sometimes it automatically gives you the right kind of spaces and indentations. And if you type, if you want to create a list like this, natural numbers, and then if you open the brackets and hit enter, actually not that way. So I have an extension that prevents that from happening, so let me disable that, reload. All right. Okay, when you open the brackets, and if you hit enter, you can see that the first bracket appears where it was, and then on the next line we have an indentation, and then the closing bracket appears on the beginning of a new line after our statement. So here, for example, we can enter -6, -5, -4, and then here -3, -2, -1. Okay, something like that. So this is how we like to format lists in Python. And the same goes for other types of brackets that we might have. If we have a dictionary, and again, when you open the curly braces and if you hit enter again, VS Code gives you this, automatically gives you that indent that you want. Okay, so next thing is, the next rule is about comments. So whenever you want to write comments for your code, you have to type the code that you want, and then, for example, y equals 100, and then 2 spaces, and then a hashtag, and then 1 space, and then your comment. Okay, this is an inline comments, and this one is called an inline comment. So again, remember these 2 white spaces, and here I have a visual notation for that in my VS Code. You can also enable that, and this is basically how we write inline comments. Now the next important thing is how we use blank lines in order to separate different parts of our code. So the rule is between classes, different classes, between different functions in our main program, we always put 2 blank lines. However, inside of classes, we only put single blank lines between methods. So let me show you an example here. Okay. All right, so you can see that I have 2 blank lines here, 1 variable defined, 2 blank lines before the definition of the class, and then inside of the class I have 1 blank line between the methods and the class definition. So that's an exception. Whenever we're in a class, there's only 1 blank line needed. And then when you have a definition of another class, again, we have 2 blank lines because we are in the main program. And then this was the second class. You notice the 2 blank lines over here. And then again, another 2 blank lines between that class and then the definition of a top-level function in the main program. And again, if you need to define something else, again, you're going to have these 2 blank lines. Okay. Okay. Any questions? Yes? I think the name, oh yeah, the camel is the one that the first letter is, yeah, that's right. Okay, I should fix that. Yeah. So this casing for the class names is called Pascal case, and camel case is something like this: my var. The first one is lowercase, and then the second one and the ones after that would be uppercase. Okay, now something that really, yes.
Yeah, so in terms of the comments, do you have a preferred length?
For the comments? Yeah, so for PEP 8, we're limited to the 79 characters, so unless it doesn't go beyond that 79 characters, then we're fine. If you go beyond that, you can again insert the comment on a new line or use block comments, which I'm going to discuss next. Okay, so question is, if you have multiple functions, are they separated by single lines or double blank lines? Yeah, so outside of a class, in the main program, we always separate these blocks of code, classes and functions and everything else with 2 blank lines. However, inside of a class, that's an exception. Okay. All right, and then from the doc strings that we have talked about in the previous lecture, you probably know at this point that we can enter pieces of text like this in our code with triple quotes, and then that's called a block comment. This is called block comment, and we can go on for many lines. Okay, something like that. All right. Now, something that really bothers me when I read code from other people is not respecting the right convention for white spaces. So, for example, if you write something like this, my list, and then do this 1, 2, 3, 4, I'm going to deduce marks. Okay. In Python, you have to have a white space after each comma when you produce a container, basically a list or a dictionary or anything like that. Okay, so always a white space after the comma, not before the comma. Okay, and not after the brackets. Okay, that really helps the readability of your code. And then white spaces around operators. So whenever we have an assignment operator like this equal sign over here, we also have to surround that by white spaces. Okay, so this would be wrong. Okay, and also when we do mathematical operations, for example, something like this, 54 plus x, we have to be sure that we surround the lowest level operator by 2 white spaces around that operator. So here, I want to have 1 white space here and 1 other white space here. And again, for the assignment operator, 1 white space, 1 white space. Okay? And if we have several operations going on here, we don't need to put white spaces between the inner ones, just the outer ones. Okay? Also, one other important convention in Python, when we define functions, for example, define my func, and then here I want to specify optional arguments, it's very important that you don't put white spaces there. So default, for example, this is a default argument called default n. I have to type it like that, not like this. I know that in R, it's different, I guess. You have to surround that with white spaces. It could get confusing, but we'll have tools in order to tell us about those kinds of problems. Okay, so it should be like this, and that's an exception. Okay, and then white spaces when we work on slicing lists. So we have 1 single space on each side of the column notation, okay, like we have here, 1 single space here, 1 single space here. And when we use this double column notation in order to show the step size and we want to use the default arguments, there is no need to write it like that. Okay, and again, all of these particular conventions, you can find a lot of examples for them on the Python documentation, and I've also provided another link from another weblog called Real Python, and they have also a very nice set of examples what to do and what not to do. Okay, and the final thing about white spaces is when we define dictionaries, and you might have noticed that we put 1 single white space after the column that comes after the key, but no white space here. Okay, and this is something that you'll get used to it. In the beginning, again, we have tools that we can use in order to be reminded of these conventions. But as time passes, you'll get used to reading code in Python. You'll see that you're going to use this naturally. Okay, so again, 1 single space after the colon here and 1 single space after the colon here. No spaces before the colon. Okay, so this is a lot to memorize. In the beginning, you might say, okay, how am I going to memorize this always? And I'm going to miss something in there. So we have tools called linters and formatters that will help us with that. So what is linting? Linting a linter is a tool that basically tells you what is stylistically or syntactically wrong with your code. Okay, so you might have seen that here, for example, when I type these things, VS Code shows this red squiggly lines beneath the code, and it's telling me something is wrong here. For example, it tells me that n is not defined, and that's something a syntactic error about my code. And stylistically, I will also be, for example, this is a stylistic error. It says that on indent not expected, for example, in this case. So I'm going to show you a couple of examples about how linters work. And let me copy this over here. Okay, So a number of famous linters are PyCode style, PyLint, PyFlakes, Flake 8, and you can look for them online and see what each one does. Some of them are only check for stylistic errors, some of them only check for syntactic errors, and some of them check for both. For example, PyLint and Flake 8 check for both kinds of errors. And in order to use them, there are a few ways. One of the harder ways is to have, for example, Flake 8 installed, and you can do that by install this in your Conda environment, whatever it is. So you can do it right from VS Code or from your terminal by running this command. Okay, conda install, and this gives the channel from which to install, and then Flake 8. And when you do that, you will have access to the command line version of Flake 8. And the way that we can run this is something like this. So here I have a file here called bat_style, and that's the content of the file. It's a really ugly file in terms of style. You can see how unreadable this is. And let me run this Flake 8 on this file and see what it says. So here I'm going to say Flake 8, and this exclamation mark that I have here tells VS Code to run this particular command in the shell. Okay, so that's just a shortcut. I can do it in the terminal, but it's easier to do it here. So it's actually a shell command here. Flake 8 and bat_style.py. Okay, so you can see that it's giving me a lot of, showing me a lot of errors here. So white space after this, missing white space, continuation line, indentation not a multiple of 4, and things like that. Okay, it goes on and on. However, it might be, I guess it's difficult to run this every time and look for those particular errors and look for the lines where these errors happen. So I'm going to show you ways how to do it in VS Code. But for now, let me also try Flake 8. And again, if you don't have that installed, you have to first do the conda install, for example, PyLint in this case, and then use it as this bat_style.py. Okay, and this is a different linter, and you can see that the formatting is different. The kind of errors or warnings that it gives us is also different. So yeah, this is just a demonstration of how these linters basically work. They read the code and tell us what's wrong with the code, either stylistically or syntactically. Okay. Any questions about linters so far? I told you this lecture is going to be easier. Okay, so let's move on. Now we have all these kinds of all these information about what went wrong with the style of our code. Now, how can we actually automatically format the code that we have? Because it would be very nice if we can basically style our code automatically, because the rules are there, the warnings are there, so why not just format it right away? So one tool that we can use is something called Black, and Black is a package that's a formatter, and again, that's something that you have to do install using a command like this. Let me paste it here. Okay, and I forgot to tell you that if you do this in VS Code, you have to supply this -y, otherwise it will stop where it asks you for confirmation, and then you can't actually enter -y. So that's in VS Code. So be sure to include that in your command. And when you have that installed, I hopefully have that installed on my machine. Let's see. Okay, so I have that already installed, and now let me run that on that bat_style.py.check. Okay, and it says would reformat bat_style, meaning that there are errors in bat_style that the formatter would fix. And yeah, if we run it without the check, it would actually go ahead and reformat the code. But again, this is a command line command, and it's probably not very convenient for us to do the formatting this way. Now, I'm going to show you how this works if we have the code inside of VS Code here. Okay, so this is the bad, a code that has a wrong style everywhere, a lot of mistakes, a lot of errors. So what we can do is that if you have black installed, if we right-click here, and let me do this, right-click here and choose Format Cell, look what happens. Okay, you can see that now the code was automatically formatted and things became just much nicer. Let me go back, show you once more. Maybe you could take a look at this if-else statement and everything here and see how it changes. So Format Cell, not Format Notebook, Format Cell. Okay, now everything looks much nicer. Okay. And one thing to mention is that if you have this tag, FMT:off, it tells the formatter that, hey, I'm deliberately doing it this way. Please don't touch this piece of code that comes after this tag, FMT:off. And FMT:on is the default, meaning that you can go ahead and format this the way that you want. So check that out again. Here, I have this code like that. And then if I do Format Cell, it does it like that. Okay, and now you might ask, the formatting for this block of code actually looks good, except for the white spaces, double white spaces here. So why doesn't it format it like that? For example, why doesn't it do this? So this black formatter, depending on how many elements you have inside of your container, it decides whether to put that on one line or whether to break it apart into several lines. Okay. Any questions about this black formatter? And in JupyterLab, we have a similar option in the menus. If you look for it, I guess it's in the edit menu. It says apply black, something like that. Or I think it also works with the right click on the cell as well. Okay. So now I'm going to talk about how these things work in VS Code. So I showed you how to format code, but I didn't show you how we can do the linting inside of VS Code automatically. So in the world of IDEs, there is this thing that we call language server. And language server is basically a tool, a program that runs on the IDE, and it's constantly looking at your code and tries to, as you type something, it will look at your code and say, and according to one of these linters that we talked about, it passes that code through that and sees whether this is stylistically correct, syntactically correct, or not. And you might have seen this thing showing up in VS Code. For example, here, if I hover on that, it says Pylance at the end of the line, right? Pylance. So Pylance is the VS Code's default language server. It's supported by Microsoft, just as VS Code is, and it's an incredible language server. It's constantly looking at your code, and it also uses AI in order to optimize the kind of suggestions that it gives to you. So Pylance itself is just a server, and under the hood, it uses one of the linters that you choose. So, for example, if in VS Code you press Shift, Command, and P, or on Windows you can press Control Shift P, this window opens up, basically something like a command shortcut. And here, if you type something like this, select linter, okay, and hit enter, you can see that currently my linter is pylint. Okay, I can disable that or choose another one. So here I have to probably reload my window. So let me work on this .py file instead. Okay. Let me show you this. Reload my window. Okay, you can see that nothing is showing up in the Python file right now But again, if I select my linter and let's choose flake 8 here, okay, you can see that in my window over here showing the problems, it immediately starts showing me different kinds of stylistic errors. So you can see that these are all prepended by the word flake 8, meaning that I'm using this particular linter. Okay, I can change it, for example. I can change it to, let's say, PyLint. Okay, and you can see that VS Code starts analyzing again, and now it gives me different kinds of stylistic errors. So here you can see at the end of the line it says PyLint this time. Okay, more than one statement on single line, or for example here it says missing class docstring. Okay, and it shows you here in the code and also shows you a full list here in this window that you can pull up by pressing Command J. Okay, this window over. You can also pull up that window by pressing this this button here, toggle panel. Okay. Okay. Any questions about this linter in VS Code? Yes.
So you get that list of options by having them installed the way you just.
Yes, yes, exactly. So in VS Code, it shows you the list of the options that you have for linters, PyLint, Flake 8, but it may not be installed. If you hit enter on that, it says, do you want to install that right now? And it installs that in your current environment. Okay? So it automatically shows the list of the famous ones, and then installs that for you if you want. Okay, any other questions before we take a break? All right, then let's take a break of 5 minutes or so, and we'll be back with the rest of the lecture. We have one announcement that Spencer wants to make.
Hey everyone, me again. We're almost there. 4-day weekend. 2 things. First thing, if you haven't already, Renzo made a new Slack channel called Networking. It's one that you actually have to join. So you just go to browse channels and then type in networking. Make sure you go on there. We're all sharing our LinkedIn pages and stuff. So thing number 2, the survey for feedback about block 1 so far. That is closing today at 12. Probably 12:20. So that's when 523 is done. I'm going to shut it down. You won't be able to do it anymore after that. So make sure you either do it right now, if you haven't, or after class. You have a lot of time to do it. So you can make the program better, you guys. It's worth it. That's it. Thanks.
Okay, so now let's just for a bit talk about Python scripts. So far, we have been, I have been providing you with the lab notes and lecture notes inside of Jupyter Notebooks. And Jupyter Notebooks is a great environment for exploration and for analysis, for having text alongside plots and figures, and then runnable code inside of the notebook and everything. So it's very good, particularly for data science projects that you want to explore something, you want to do a lot of analysis, you want to plot a lot of graphs and things like that. But eventually, when you have developed your code and it's ready to be packaged inside of functions for others, for it to be useful for others, you want to put everything inside of .py files. This is the main method that we want to run Python files. Basically, the basic reason is that when you have some production code you want others to use, you want to put that code as the backend of some service that runs on the internet, you want to put that code on a server. And on the server, there's no longer like any visual environment that you can use, at least conveniently. And you want to make everything automatic using makefiles that you're going to learn later, for example, something like that. So for those cases, when we're sure that our code is well tested, works fine, we want to put everything into .py files. Okay? And I think in the first session, I quickly showed you how you can run Python code inside of .py files. Do you remember how to do that? So basically, the way that we do that is very similar to Jupyter Notebooks, with the difference that we no longer have anything like text inside of our notebook or images or anything. So plain and simple files. For example, let me say program.py. Okay, and now this is a Python file. VS Code automatically recognizes that and knows what to do with the code inside of that in terms of the linters and formatters and everything. And we can do whatever we like inside of here. Print hello world, and maybe print, do a list comprehension here, I raised to the second power for I in range 10, something like that. And I'm going to save this file, and then in order to run this Python file, you should do it inside of the terminal. And basically, first I have to check whether I'm in the right directory, which I'm not in this case, lectures, and here I should have my file, and yeah, program.py, okay. Now, I could go ahead and do this, Python program.py. And if I run that, my program runs in the terminal, and now you can see that it's now easy to put this file on a server and then connect to that server through terminal and run your code easily. And again, this is not super convenient when you have, for example, you want to do some plotting. The plots might not show up on the server, or you want to break apart different parts of your code. But when you're sure about everything, you want to package things together, this is the way to go. For example, in your capstone projects later on next year, when you develop some library or package for the project that you have, you might do your analysis, your code development inside of Jupyter Notebooks, but eventually we'll ask you to basically create a package, a library, which only consists of .py files, and then somebody else can go on and import your libraries and start using your code without opening Jupyter Notebooks and look at the code there. Okay, any questions about .py files? Yes? Pardon me? Oh, okay, yeah. So good question. Can we click this this play button right at the top here? Yes, that would work. It will automatically look for the right environment and the right folder and does everything automatically for you. But in case that's not available for any reason, then you can navigate to the folder and run python.py. Python and then file name.py. One other thing that's particularly useful with this case is that if you have, for example, created a complex function and you want to supply some arguments to it, you can also do that from the command line. So you can have something like this, Python, and then here you can provide some arguments. For example, if I have a function that takes in this something like this, diff my print I, and then it does this printing I times. Then your program could take that I as an input here. For example, I can say 50, but I have to include a line in my code saying that I want to basically access the arguments that the user has supplied. So we won't go into details of that, but basically you can provide arguments here, and then the Python interpreter will feed those arguments into your program and runs it for you. This is again useful when you want to make everything automatic. So you want to write a bash script or shell script. You want to do something automatically, run Python code automatically. Okay, any other question about running .py files? And you will go into details with these kinds of files and how to package these files together in another course in MDS. So don't worry too much about this. This is just to show you that this is something we have to do. Yes?
Is there a quick way to convert an IPy notebook into a Python file or then copy and paste?
Yeah, so good question. Is there a way to convert a Jupyter Notebook into a .py file? I believe that VS Code does that for you, but even if it doesn't, so let me check. I guess we had a button up here for that. Nope. Or maybe here. Okay. Export. Yeah, so let me see. Okay. So if you do that export, it gives you something like this. Okay. And this is still a Python file. When you see these comments with double percents, and that inside of VS Code only, if you click run cell, it will open up an IPython window that only runs this cell for you inside of that window. It's just a very quick way to run things inside of .py files, because if I do this here, let me get rid of this. If I do this here, if I run my code, it will run from top to the bottom without stopping. That might not be helpful. I want to maybe test just one part of my code. And this notation creates a cell for me, and then I can run that cell by itself. Okay? And you can do that in your .py file anywhere. So I can add this comment, double percent. You can see it automatically turns into a cell. So I can, again, do, let me run this cell. So print, my print and 50, and run this, run cell. So let me remove this. Yeah, whenever something like this happens, you can reload your window and it probably solves your problem. Okay, now let me do that again. Save this file. Okay. So it says connecting, and then it runs this cell for me. Okay, so this code have to be something like that, actually. Okay, now you see all the numbers showing up. So any other questions? Okay. This is actually an alternative way for you to explore Python code, just to create a simple .py file that you can easily version control. So that's good that I just remembered this. One problem, one thing that used to be a huge problem with Jupyter Notebooks was version controlling. So when you put Jupyter Notebooks on GitHub and you want to check the diffs, then the diffs would be pretty messy, because a Jupyter Notebook is basically a file that is structured in a particular way. It's a JSON file. You'll learn about these later on. And you can't easily find the bits that have been changed. This have been improved over time, but still, version controlling this file is much, much easier compared to Jupyter Notebook files. Here, I can easily see the changes. So this file was empty in the beginning, and now I have added these parts. Okay, but the same thing might not always be simply possible using Jupyter Notebooks. So this is an alternative way. You can add these double percents, whatever you like, and run it as a Jupyter Notebook while it is still a plain text file. Right. Okay, now if there's no questions, let's move on to the next part. Well, great. Now let's talk about something that we have been using so far, but we didn't really explicitly mention that didn't explain anything about it. And that's the concept of importing. So, just like I said today, that eventually we want to modularize our code and put different parts of our code inside of classes or functions, and then eventually we want our code to be reusable by others or maybe by ourselves. So the best way to do this is that people package their code together in what's called a library or a package. So bundle everything together in a particular structure so that other people can basically do this conda install and then grab your code off the internet and then be able to use your functions, use your classes, and basically use whatever you have developed. The way to do this is that you'll learn about how to create Python packages later in another course. But right now, we just want to know how is it possible to basically use the code that other people have developed. So suppose that I have a large code file containing a lot of functions, a lot of classes. So if I want to use these classes and functions over and over again, it's not a good idea to every time just copy that whole code into another project and then start using it again, and then copy the whole code. So by putting everything inside of functions and classes, we have avoided some repetition, but still we have to copy the code into our new project again. In order to avoid that, we can put our Python code into what's called a module. So a module is nothing but another .py file that contains your classes, your functions, your variables, whatever you want to tuck away inside of a separate file, and you're sure that everything works there. I want to just put it there and use it whenever I like. So that's called a module, and the way that we can import modules into our Python file or runtime is by using this keyword import. So you have seen this. For example, in the previous labs, we've been using NumPy. We'll learn what NumPy is later on. But basically, you can do it like that. So I have NumPy installed on my system. You also have installed that as a part of MDS instructions. And if you do this and do import, now you're going to have access to all of the functions and classes and utilities that are defined inside of NumPy. Okay. So now let me show you this example that I have here. So I have this file called, sorry, let me close this for now. I have this file that I also put on the GitHub repo. This is called wallet, and it basically just defines a class called wallet that does this. It buys items and reduces your balance, or it sells item and adds to your balance. Simple operations as that, and it also sometimes raises an insufficient cache error for you. So pretty standard class. We have been working on defining classes like this in the lab or in the previous lecture. Okay, so I have defined this. I know that this is working. I'm going to put it in a separate file like I have here in wallet.py. And now suppose that in my code, I want to be able to use that class. So the way that I can do it is to basically import that file. So I'm going to type import wallet. And you can see VS Code recognizes that this file is in my directory, and I can do it like that. Okay, import wallet works. And now let me see if we have really imported that. So note that I'm going to put this right here. Okay, all right. So let me see if I have access to this class, and note that the class is with capital letters. And I'm going to type wallet, and the way that I can access items, functions, classes inside of a module is again by using the dot notation. And as soon as I press dot, I can see wallet, which is the class, and insufficient cache error, which is a cache error that I have defined here, an exception that I have defined myself. So I have access to both classes inside of my module. And you can see that without copying and pasting the code into my Jupyter Notebook, I have access to all those classes. Okay? All right, now I'm going to show you, so let me do this actually. So let me assign it to a variable here, wallet dot wallet. I just want to initialize that and give it a value here. Let me see what arguments it takes. Okay, it just takes a balance. Let me do 100. All right, it worked. And now my wallet dot balance. Okay, so it seems like the importing has been done correctly and successfully. Now, it might be a little bit verbose to always include that wallet dot something. So we can actually create a shortcut or what's called an alias for that module. And this is something that, again, you have seen in the lab. We can import wallet as W, for example. And here, I'm just creating a shortcut for wallet. I'm saying that recognize this wallet module as W. So now what I can do is to do something like this. So now if I get rid of this here and do W dot, again, I have access to my wallet objects. And yeah, I have to run this again. And there we go. Okay, and this is what you have seen in the lab. Import numpy as NP. And again, that NP is something that we decide to use. You can name it anything that you want. Yes?
Question. If your modules are in a separate folder, let's say your notebooks and
Yeah.
source, what's the best way to
Sure, great question. I'm going to get to that actually in the next part here. So let me just quickly discuss another way of importing functions, and then we'll get to that. So, okay. So one thing is sometimes these packages are really huge, and we don't want to load all of those functions and classes and objects into our Python runtime. So in those situations, we might want to just grab one particular object, one function from our module, and then that's all that we need. In those cases, you might have seen this syntax elsewhere, and that's something like this. We can do from wallet, that's the module name, import a particular class, particular function, okay? And here, I want to import the wallet object here, okay? And then, again, that object will be available. However, since we're using this from keyword, the wallet object is directly loaded into our Python runtime here, and I can directly use it like that. Okay? And I can do this, and again, it works. Now, what is one downside with this? Yes? Exactly. One problem would be that there's another package, another module that contains the same object, and basically you will overwrite that if you do this. What is another problem with this? Maybe in the context of this lecture. Yes?
I was just thinking, like, if you only take part of the package, but maybe you need other parts of the package to make that
Sure.
work, and
That's a fair concern. So if you just import a class, a particular object, particular function, then it turns out that we need other things from that. Then we have to do the import again, and things get messy. Sure. What else? You may not notice that from this very short code, but suppose that this is 1,000 lines of code. It actually decreases the readability of your code, because now we might not have an idea in the line 700 where this wallet object is coming from, right? But if we prepend that with, for example, in the previous case with wallet or W, that's still an indicator that, okay, this exists in that. I think in R, you have something similar. So inside of a package, like, I don't know, package, you'd use the double column notation, I guess. And that makes it a lot more easier to see where this particular function is coming from. Especially in R, you have plot in so many different packages, for example. So this is a way that makes your code more readable. Again, this is a decision that you have to make. And if you don't want to use an alias at all, but still have access to all of the functions and objects, you can do star. From wallet, import star, and that imports everything. But you don't need to use the alias anymore. Okay, now we come to your question. This module wallet actually exists in my current directory. Okay, so if I show you where we are, pwd, We are here, CD lectures. Okay. And now you can see that wallet exists in the same directory as our lecture notebook here, and that's why I can use it. Okay. So what if I have this particular file here inside of this data directory, and that's called hello. Pretty small module. Okay, and it defines this particular variable and this small function. Okay, so now let me try that. So let me import, or let's say from hello, import hello world. And you can already see that VS Code does not give me any auto-completion. Okay, so let's run that. It says no module named hello. Okay, and this also happens when you haven't installed a package and you're trying to use it. So the thing is, Python only recognizes the current folder that your .py file or notebook file resides in, and a couple of system paths which are set, for example, the path set by Miniconda, in order to know where to look for installed packages. That's it. Your current folder is the one that Python will be looking for modules, or in a particular folder on your system that contains the installed packages. So in order to make this known to Python, there are a few ways. One way is that to basically add that particular path to where Python looks for those files. The way that we can do this is by this. So we can import a module called sys, and that's Python built in. And let me show you what's inside of this default paths. So sys.path, and if we do this, look at that. So this is the folder that I'm right now inside of, okay? And these other ones are just system folders that Miniconda uses, okay? So Python only sees this one along other ones that belong to installed packages. Now, how can I make that data folder known to Python? I can basically do something like this, sys.path.append. Oh, the good old append method. And here I'm going to say data, and that's the folder where I have stored my file. You can see that this is data. Inside of that I had hello.py. Okay, now let's do that again. And let me now again check out sys.path. Run that. And now you should be able to find data. Okay, so that's here. Okay, now let's go back and try this again. And now it works. So that's one way to make different paths known to Python if your module happens to be inside of another folder other than your current directory. The other way is to basically take and copy your file, your module file into, there's this folder inside of where Python is installed. It's called site packages. If you put it there, Python will also recognize that, but that's not recommended. Okay, and now just as an example, you can see that here I'll have, let me import everything from hello. And then just to show you that I actually have access to everything inside of hello. So for example, we have planet, this variable called planet. So let me print planet, and you can see Earth, okay? So it means that our method worked. All right, any questions about this part before moving on to the next part? Yes? It's not possible that two folders have this exactly the same absolute path. So if you look at what it gives us in the output here, look at this. This is an absolute path. It says from the root folder of my computer, follow this path all the way here. Okay? And that's the way that Python knows how to deal with this. Okay, so that's an absolute path. It's not possible to have the same folder name with the same absolute path. Yes? Yeah, I think, yeah, that works. That works. I think Python interprets that as, expands that double dot and does add that for you. That should be possible. Yes, because absolute paths belong to your computer and they might not work in another computer. Yes, that would be the best way to do this. Yeah, but I should try that. I don't have a folder like that right now, so I should give it a shot and see how it works. Okay, any other questions? Yes? Oh, great question. So when we append this data path, will this be there forever? No. So as soon as you restart your Python environment, your kernel, your Jupyter notebook, then everything will be reset. And you have to include that in your code if you want to always to be able to access that. Yeah. Okay. Now this was almost it about imports and style guides and Python packages. But before ending this lecture, let me just quickly go back to the thing that we discussed in the previous lecture about how Python works with copying variables and data between those variables. So let me just show you a couple of examples to maybe clarify that further. All right, I'm going to close this. I don't need it anymore. All right. So we talked about this in the last lecture. So we have x equals 100. And suppose that I want to have the value 100 in y. So I'm going to make that equal to, make y equal to x. So basically what I'm telling Python is that x is 100. Take whatever is inside of x and copy it into y. Okay. And now this, this should work, y, and this also 100. And now, suppose that before doing that, I'm going to change the value of x to 2, okay? And now x should be changed, obviously, and y shouldn't be changed. That's what I expect, right? Okay, that's great. Now let's see another example, what we discussed previously. So this is a list this time. And I want to put every value inside of x into y, okay? And now let me do the same thing. So I'm going to do x at index 0 equals to 2 at this, for this instance. Okay. So let me first print x just to see that the change has been made. So x was 100, then I assigned the value 2 to index 0, and now this worked, okay? But remember that I had copied x to y, so what I expect is for y to contain list 100. But that's not the case. And the thing is, when we do assignments like this for mutable objects, like lists or dictionaries or things like that, Python actually doesn't copy the contents of those containers. It only copies the reference to that container. Okay, so it's pretty much like if I give you a link to my Google Drive, to a folder, and then you have the link, okay, you can view that folder. But if I go home and change the contents of that folder, delete everything inside of that folder, when you look at that, you'll see that everything is gone. You don't have your own copy because what I gave you was only a reference to that location. And this is basically how mutable containers work in Python. And you saw that for integers or floats or things that are not mutable, what we expect is the behavior that things are copied, and that's actually what happens. Okay. Now let me show you a couple of more examples here. So what if I do this? What do you think will happen to y? Does y still remain equals to 100, or does it get the new value 2 inside of square brackets? Can you speak up? Stays 100. That's correct. Why is it the case? Yes. Yes. Yes, exactly. Because basically, here what I've done is that I didn't reach into the object and change some value inside of a particular index. I have actually reassigned it to a totally new object. So when I do square brackets 2, that's Python sees that, creates a whole new object, and assigns it to x. Or basically, let's say, assigns x to that particular value. Okay, so that's reassignment. Okay, this is reassignment, but this one, let me do this. This one is not reassignment. Okay. All right. Now let me show you one other different type of behavior here, and that's about NumPy arrays. So let me copy this. So NumPy arrays, we'll learn about them in the next lecture, but they're pretty much like lists. We'll learn the differences, but for now, just look at the behavior. So in this case, let me import NumPy is NP. All right, and then do this, and then if I check out the value of y, you can see 1, 2, 3, 4, and 5 is added to x, and y has also changed. Okay, so that's pretty much what we expected. However, if I do something like that, we know that in Python this is basically a shortcut for x equals x plus 5, right? We've said that this is a shortcut, but in Python terms, this actually behaves differently. So it defines a new object, and now if you do this, okay, and now look at y, and you can see that y is something, sorry, 1 second. So what happened here, okay, let me go back to this. Let me show you the IDs of those objects. I think that would be more helpful. Okay, so here you can see that Python assigns different IDs. Sorry, what I was saying was vice versa, was the opposite of this case. So when we do this addition, because we are reassigning this to the left-hand side, Python actually creates a new object, and y retains its values while x has changed. However, in the other case, we're using the plus equals operator instead of that plus, and this is not reassignment, this is changing in place, okay? And if you look at that, you can see that the ID of those objects, basically the place in memory, has not changed. So be mindful of that when you're doing these kinds of operations. For keeping track of references of objects, this is reassignment, this is not, okay? Reassignment changes the memory location. This plus equals does not. Yes? Okay, so that depends on how the package developer defined that particular operation. So just like we learned in classes, you can define the particular way that this operation works. For NumPy, this is the way that it works. For other packages, that's the developer's decision. Okay. All right, so I have a couple of extra notes here in the lecture notes. You can go over them if you want. There is basically just one more point here, and that's, sorry, yeah. No. With pandas data frames, we don't usually use, I don't think we have this operator plus equals. But with pandas data frames, this copying thing is also a concern, and I will talk about that in those lectures, because it's a little bit more complex than this. So there is just one other thing that I wanted to mention, and that's if it happens that you actually need to take a full copy inside a list to the deepest level of that list, there is a method for doing